Mike de Wit, he's a geologist. He's been with De Beers for many years. He's traveled all up and down Africa. He's found diamonds everywhere in Africa. He's a real African geologist. And there seem to be plenty of those about. So he's going to talk to us, as you saw today, about the discoveries in Botswana. Mike, thank you very much for coming and for your preparation, and we're looking forward to your presentation.
Great, thank you very much, and good afternoon to everyone. I'd like to take you through the history of the discovery of diamonds in Botswana. But before doing that, I thought it'd be useful just to give you some background on a few principles that some of the non-geologists may find hard to understand. So, oops, sorry. If we look at the next slide, diamonds, for those who are not very familiar with the subject, come from about between 150 and 200 kilometers below the crust in the upper mantle, and they are brought to surface by volcanoes that have been referred to as kimberlites. These volcanoes bring the diamonds to the surface. And in addition to bringing diamonds to the surface, they also have a whole suite of very nice looking minerals, such as garnets, the purple ones on the screen. There are some olivines, the sort of creamy color minerals, and then there are some ilmenites and spinels and a beautiful chrome diopsides. And I mention these because these are the minerals that we use to explore to find kimberlites. And we'll get back to that a little later. At presently, there are about 7,000, in the order of 7,000 kimberlite known globally in the world. But not every kimberlite contains diamonds. And it's only about 10% of those kimberlites that we know that have diamonds in them. And then again, not all of those 700 odd kimberlites that have some diamonds in them are economically to mine, and only about 10% of those are being mined at the moment. So we know of about 70 kimberlites globally that have been mined, and out of those 70, there are only 7, which is quite an interesting number, but it's about 0.1% of globally known kimberlites that we can call world-class mines or tier 1 deposits. And 2 of those occur in Botswana. So Botswana is a big player in this game. Now, in addition to understand the relationship of diamonds and kimberlites, kimberlites occur in many environments in different geological terrains, but they only carry diamonds if they intrude through what we know as cratons. These are the thick, old, cold parts of the Earth crust here in dark blue. And only in those areas that you will have a chance of finding a kimberlite that will have diamonds. So the diamonds come through with the kimberlites, and the kimberlites should really be intruded into a craton to have a chance to be a diamondiferous body. Now, in addition to that, when we look at kimberlites on surface, they expressed as almost, well, not entirely, but almost as circular bodies, so volcanoes, and it depends on their erosion levels, whether you're looking at the upper part of it or the lower part of it. The lower part will be much more irregular. But we express the surface areas of kimberlites in terms of hectares. So if you look at, for instance, Orapa, which is one of the kimberlites in Botswana, it's the biggest kimberlite mine that's been developed. It's about 118 hectares. We see Premier Mine is the biggest kimberlite in South Africa. It's about 32 hectares on surface, and so on. So we express the size of the kimberlites in terms of the surface area. Then we also talk about grades, and I'll mention that during the course of this talk. Carats per 100 tons. Now, 1 carat is 0.2 of a gram. So it gives you an idea of how rare diamonds really are in these rocks. They are mined. Some mines have a grade of 1, which is a mine in Lesotho. But some of the kimberlites have grades up to 300 carats per 100 ton. So the grade varies quite dramatically. And it's not the only thing that restricts the economic part of it. It's also the value of the diamonds within those kimberlites. They can vary also very much. And these values are average values in a kimberlite. There are some kimberlites that have diamonds in them that are only $4 a carat, and we find those in the DRC. But we also find kimberlites that have diamonds in them that are worth over $2,000 a carat, such as in Lesotho. So there's quite a lot of variation in the sizes of kimberlites, in the grades, and in the values of the diamonds that they contain. And the last thing that I wanted to mention is that kimberlites normally occur in clusters. And this is a radar image of central Botswana. These are the Makgakgari pans. If for people who know Botswana, there's the Letlhakane River. And this is the Orapa kimberlite cluster. And you'll see there's a whole range of kimberlites, about 85 kimberlite intrusions, but only 4 of those are economically mined. The rest they may contain a few diamonds, or they are what we call barren. So that gives you a bit of background of kimberlites. This is a map of Botswana showing there's Gaborone, the capital, Francistown, Maun. But it shows you the distribution of the main mines in Botswana. There's the Orapa mine in central northern Botswana, and the Bechuanaland mine in southern Botswana, the 2 big mining areas. And then there are some 2 other areas that have been mined, but that has been a bit of a disappointment. So in Botswana, we've got nearly 400 kimberlites, 6 operating mines. In Orapa, there are, in fact, 3 or 4 kimberlites that are being mined. We've got 2 closed mines, and there are 2 projects that are being looked at from a feasibility point of view. Now, Botswana has only been mined, diamonds in Botswana have only been mined since the early 1970s when the kimberlites were found. And it has since then produced over 800 million carats in total, which is 14% of the total global production that have ever been produced. So it is an enormous amount of diamonds. If you compare that to South Africa, South Africa has produced about 12% of the global amount of diamonds that we know of. And that has been going on for 150 years. Botswana has been going on for 50 years. So it shows you how fast Botswana is producing such great quantities of diamonds. Globally, the production of diamonds is about nearly 6 billion carats from the first diamond that was ever found. Okay, what I wanted to do is just run through quickly the phases in Botswana, because Botswana has seen has a bit of mining history, and it is quite interesting to run through it. We will have a quick look at the prehistoric side, some of the early stone, middle stone, and late stone artifacts. We'll have a look at when the first gold was found in 1866 in Botswana, and how that changed the thinking in that country. And then the modern diamond exploration, which really started in the early 1960s. So if I can take you to Orapa, which is over here, and that's roughly in that northeastern part of Botswana. These are the Makgakgari pans. There's the Okavango Delta, there's Maun, the Beteti River flowing into the pans if it rains enough. And these pans have been shrinking for a long time. There are early artifacts that have been found on the shorelines of these pans. And these artifacts show that people have been chipping away on these rocks and pebbles that they found on the edges of the pans. And it's interesting to see that the oldest tools that they were made are sitting at a higher elevation than the younger tools sitting at the lower shorelines. There are various shorelines that are associated with the shrinkage of these pans. And in one of the kimberlites, right at the edge of the pen over here, this is a kimberlite BK9, and I'll get back to the number, why it's called BKs and AKs in a minute. But this BK9 kimberlite has a cover of about 12 meters of Kalahari cover, sands and calcretes. And at the base of that, they found some artifacts. So it tells you how fast the Kalahari Basin has been infilling in this particular part of the country. Now, if you look at some of the other prehistoric mining that's been going on, one area, Tsohillo Hills, I don't know if anybody's been to Tsohillo Hills, it's really worth a visit. Beautiful place. And it's got some small mines in there where people were digging out speculite and hematite, mainly for pigment use and also to make some beautiful drawings of rhinos. And then in the northeastern part of the country, there are some prehistoric copper mines that people have been digging out copper from the 13th and 14th century. And that's really based on dating of charcoal that people have found there. In addition to that, then iron came on the scene, copper, and later on there's evidence of some gold workings. So that gives you a bit of an idea of the prehistoric background. Now, before I go into the historic mines, just a few interesting observations is that in 1866, gold was discovered in the Tati concession. That's the Tati concession here, right in the eastern part of the country. In 1885, the gold diggings didn't last too long, because at 1890, 3 years later, diamonds were found in Kimberley, and a lot of people that were mining the gold here moved down to Kimberley. But in 1855, the southern part of Botswana was included as a British protectorate. And 5 years later, the northern part of Botswana was included into the British protectorate. But it was a time when Cecil John Rhodes was expanding into the Rhodesias, both southern and northern Rhodesia at the time. And he already was building his railway line from Kimberley to Bulawayo through the eastern part of Botswana. And the chiefs of the main chiefdoms in Botswana were very concerned that Rhodes was going to take over the rest of Botswana as well, like he did in the Rhodesians. And the main three chiefs, Batum, Sebele, and Kama, who was the chief of the Bangawata Reserve, went to England to plead with the British government not to be transferred to Cecil John Rhodes's company, the British South African Company, which he set up, but to remain as a protectorate under the British government. And they managed to convince the government that was the way to go. So Cecil John Rhodes didn't get his hands on Botswana, but what happened was in 1896, there was a company set up, the British West Charterland Company, who wanted to explore for gold and diamonds in northwestern part of Botswana. And I did some digging of in the company files and registration offices to find a bit more about this British West Charterland Company. And it was, in fact, many of Cecil John Rhodes' friends and colleagues that set up this company and really were doing it on his behalf. And they set up a expedition that was led by a guy called Siegfried Passarge, a German. And they traveled from Cape Town to Kimberley, and then from Kimberley to Palapi, from where they then traveled by ox wagon to almost to Maun, in a place called the Kwabi Hills, where they set up a base, and they started exploring for gold and diamonds in this northwestern part of Botswana. And these maps that I show you are the maps that they produced, that Siegfried produced, actually, the first geological maps of that country. They traveled in the later part of the year to the Kwabi Hills. And anybody who knows Botswana, October, November, December are just awful months in terms of heat and dryness. Many people died on that traverse, but Sigvard did his work, and this is one map that he did right on the border with Namibia, in an area that I worked in the last 10 years, and we found about 44 kimberlites there, interesting enough. But in those days, obviously, their technology wasn't the same, and they didn't really find anything. But what's interesting is that he was a medical doctor, and he ended up as a professor in geography. But he was a great naturalist, and he had a great sense of describing insects and plants and everything. And he wrote this book. It's called Die Kalahari. I've got a copy here in Claremont if anybody's interested. It's published in 1904, and it's 800 pages thick volume, all in German, I'm afraid. But one thing that he did find was he was describing some of the termites and the ants, and he suggested that these could actually be used for an exploration tool, because the ants and the termites bringing up material from the groundwater level to surface would be a fantastic way of looking for minerals. Anyway, no diamonds and gold were found, and the next person that, the first real person that has a major contribution towards the discovery of diamonds in Botswana is a chap called Alex de Tooy. He's probably South Africa's most famous geologist to date, and he did an enormous amount of mapping in South Africa. He worked for the Geological Commission in Cape Town, and then he joined the Union Irrigation Department as a hydrogeologist, and spent a year. He was sent to northern Botswana to have a look at the Magadi pans and to see if there was any way that they could dam off some of the rivers to fill these pans, and in that way to try and change the climate in that part of the world. But that wasn't a scheme that seemed to, he suggested that would work. But he did write a very interesting paper in 1933, and he described these crustal upwarps, as is shown in these black lines on his map, which developed, was the instrumentation of developing some of these pans in this part of the world. And we'll get back to these crustal upwarps as how he described them. In 1927, he left the civil service, and he became chief consultant to De Beers. And he went back to Botswana in the 1930s to do some prospecting for diamonds for De Beers and for the Anglo group. There's old Alex de Tooy and his wife, and this is when he was still working in the Geological Commission, doing his mapping in the Karoo. Now, it's what happened in the Bangawata Reserve is that Khama III signed an agreement with a gold company. That gold company was subsequently taken over by Cecil John Rhodes, who was still very keen to get into Botswana. But Khama III died, and his successor was not keen on this at all, and he took a long time to negotiate this agreement and revise the agreement, and eventually they managed to the Anglo De Beers group at the time then, obviously related to Cecil John Rhodes' British South African company, managed to get a license to get into the Bangawata Reserve. And they did some prospecting, but that didn't lead to very much. So Anglo pulled out 2 years after the agreement was signed, and De Beers continued a little bit, particularly looking at some of the gravels in the rivers to look for diamonds. And in fact, in 1938, found the first diamonds in the southern part here near Mafeking, in Botswana. So that was, but that was all that they found at the time, and they pulled out of the agreement in 1938. Just to go back to Tsikedi Khama, he was the second son of Khama III. The oldest son had died, but his son, Seretsi, was only 4 years old at the time. So Tsikedi became guardian of the Bangawata tribe. And he long resisted, as I mentioned before, the mining companies to come into the reserve. But he realized in the late 50s that that development was needed in Botswana. So he signed an agreement with a company called Rhodesian Selection Trust to look for copper in their reserve. And that then became the Bomoata Copper Company. This company had a subsidiary company working in West Africa called Consolidated African Selection Trust that were looking for diamonds. And they managed to get this company to come into Botswana to look for diamonds. Just on the side, I mean, Seretse went to England. He married Ruth Williams, which caused a major problem between Tsekedi and Seretse, as well as with the South African government at the time. But he, in 1966, did become the first president of Botswana. And recently there was quite an interesting movie that was brought out to describe his life. Anyway, to go back to exploration, the Consolidated African Selection Trust did some sampling in the eastern part of the Botswana for diamonds. And this eastern part of Botswana is not covered by Kalahari sand. That Kalahari sand only starts at the other side of that crustal earth pore I spoke about early on. And they sampled these rivers. They took stream samples and screened them, took out the heavy minerals, and they found a few diamonds for the first time in this part of Botswana. However, they followed these rivers up to the origin and couldn't find any more any diamonds or any signs for other diamonds, and decided that these diamonds had probably been derived from the Karoo rocks. There are some glacial deposits that are quite old, and they thought that these diamonds had been incorporated in these glacial deposits and were subsequently being eroded out by the present-day drainage. They did say that perhaps the diamonds could also have come from the west, but because there was Kalahari sand cover there, they were unable to, they didn't have the expertise and the knowledge how to explore over that terrain, sorry. And then the second person that had a major influence on the discovery of these diamonds was a geologist, Gavin Lamont. Now, he did his PhD in 1947 at UCT, and his external examiner was Alex de Torre. So there was already a relationship there between these two geologists. He first joined the Geological Survey of Southern Rhodesia, and then in 1949 joined the Geological Survey of the Bechuanaland Protectorate. And in 1955 joined De Beers to start exploring for diamonds in Botswana. And one of the things that he observed, and it's very much like secret passage, is the importance of termites. And there you see him sitting next with one of his geologists next to a massive termite mound. And he soon realized the importance of termites bringing grains to the surface, as had been suggested by the Eugene Moret, who wrote a book about termites called The Soul of the White Ant. Certainly a book that's worth reading if you're interested in this sort of thing. So Gavin Lamont decided he should sample the Kalahari, so he designed a sampling strategy with using a large sample team with a team leader, a wheel pusher, guys taking samples and porters. And he cut north-south lines in the bush about 10 miles apart, and the teams would walk for 5 miles down, 1 mile across, and 5 miles back. And that would be one-day work. And they would take a spade, a scoop sample every 15 paces. These would be combined at 0.2 of a mile when the wheel pusher blew his whistle, and the two bags would then be combined as one sample. They would be, after 6 samples would be taken back after 1.2 of a mile to the traverse line, and these would then be put on the truck. The truck would move a mile to meet the back-coming sample team, And in that way, they, excuse me, they covered thousands and thousands of square kilometers in Botswana. A very labor-intensive exercise, but very, very efficient. There is the scoop sampler, the guy taking a sample, he puts it in a sample splitter. The sample, half the sample goes out, the other sample gets into the bag, and every 0.6 of a mile, the two bags get combined as one sample. And in the front, you had a guy pushing a wheel, and on the wheel, he had a little chronometer, and he would measure the distances, and he also had a compass in his hand, so he would keep the guys in the right direction. So that's the way that Gavin Lamont, covered the sampling. Then he took the samples back to camp, and initially they were using gold pans to concentrate the sample. Now they were looking for those heavy minerals that I showed you in the first slide, the garnets, the ilmenites, and the chrome dioxide, and diamonds if they were there, because they are all heavy minerals, so they can concentrate in a gold pan. But it turned out that that wasn't the real very efficient way of concentrating minerals. The better way was to screen the material first, take out all the very fine clay and fine sand, and then concentrate the screed material in a jig using screens. And that turned out to be a much better way of concentrating the minerals. So the first thing that the Beers did is they went back to the area where Consolidated African Trust had found their diamonds, and they resampled that area in a very similar sort of way, stream samples along the main rivers, and they had some very similar results. They found 2 diamonds in very much the same places as Selection Trust had found, but they also, with this more efficient screening analysis, found garnets, ilmenite, and chrome dioxide. So minerals that would identify itself with kimberlites. So that was a major step forward, and Gavin Lamont for a long time had argued that they should sample more to the west, but having been there since 1955, it was 1962, they hadn't found anything in Botswana yet. Anglo De Beers decided that they didn't want to take out more licenses at the time, and they carried on working in the eastern part instead of going across. There's the upward axis that I mentioned from Alex de Toy. The diamonds were found in the Mkrutsi River, and that's the X marks the spot. That's Orapa area south of the Magadi Pan. So the argument was that the drainage had come actually from much further west, but that the axis had, the upward axis had cut the drainage off, and therefore had cut off the source of the material found in these rivers. So in the meantime, Gavin Lamont carried on sampling in the more accessible areas, and in 1966 did find the first kimberlite-looking rocks not too far from Gaborone, called the Machudi kimberlites. And this brings in the third person who was quite involved in the discovery of diamonds and kimberlites in Botswana, a gentleman by the name of Chris Jennings. He was an ex-Italian, played rugby actually for Natal, and he joined the Geological Survey of Botswana 2 years after Gavin Lamont had left it. But being a small place in Botswana, everybody knew each other, and they got quite well on in the beginning. Chris Jennings was mainly into groundwater, and he was very much involved in developing geophysical techniques to establish, to drill for groundwater for Botswana as it was developing itself. But in 1971 joined a company called Falconbridge, and in 75 proposed to Falconbridge to start looking for diamonds in Botswana. So it basically became opposition to Gavin Lamont. But in those early days, Gavin approached Chris Jennings and asked him if he wouldn't do some test surveys over those newly found kimberlites that I mentioned just now at Machudi, to see what technique would be best for kimberlite exploration. And they used various methods. They used ground magnetics, ground gravity surveys to measure density differences. They used electromagnetics, they used IP, and used potential, they even used seismics. But in the end, they concluded that magnetics was a simple and effective way of exploring for kimberlites. So then in 1966, the pressure was now on from Anglo De Beers to start, they considered pulling out of Botswana at the time because they'd been there more than 10 years and they had found, except for those two little bodies near Gabs, two small kimberlites. They decided to go across the upwarp. There's the upwarp, that's the Maklutsi Dranis, and there's the Suapan with the Orapa kimberlites position. And they decided to do a quick and dirty. Gavin Lamont took his chief geologist, Jim Gibson, and the two of them went on a crude road sampling exercise in this area. They took 17 bulk samples, scoop samples, on sheets 21, 25A and B. That's really why we're calling these kimberlites AK1 and BK2 and BK3. It's the second, third, or fourth kimberlite on that map sheet. So I will refer to these AK1s and BK2s, etc. But they spent a few days sampling, and they discovered that 12 of their 17 scoop samples were highly positive with ilmenite and garnets. So they knew they were onto something. And let's just note the date. This was in July 1966. And in September that same year, the Botswana gained its independence. And one of the things that Sir Seretse Khama, who became the first president of Botswana, one of the first things that he did was to convince all the tribal chiefs that they should surrender all the mineral rights of the tribal lands and put it into under one as a government mineral rights. So basically he said, let us share any wealth we find underground with the whole nation, irrespective of where it was found. And he was a man of great vision. In March the following year, following up on the results that Lamont and Gibson got, and of course the first thing that they had to do is get some licenses. They got the licenses, and it wasn't very shortly thereafter that the young South African geologist Manfred Marx found the first kimberlite in the Orapa province. It wasn't the one that's going to be mined, but it was the first kimberlite, and it was a great success. And in the following month, BK2, that's the kimberlite on the map sheet B, was found in March, and then on the 25th of April was AK1, which is really the big find of De Beers, and which became the big kimberlite mine. And to celebrate this 50 years later, we had a celebration conference. Manfred came back from Australia and went into the BK1 pit and just posed for this sort of celebration. It was a great highlight. Anyway, so the big kimberlite was found, the first positive sample of AK1, April 1976. These are the guys that were involved in sample processing. They had a little lab. They used a little bit of bromoform there to separate the heavy minerals. And the first sample produced, and these samples weren't very big. They produced well over a couple of thousand ilmenite, a couple of thousand garnets, and many, many chrome diopsides. And it's really a sign that you're almost on top of the kimberlite. Gavin Lamont then actually sent me the first grains that were picked and found from Orapa. I still got them here at home as a memorandum. If you look at the air photograph of the time that before the discovery, and this is an air photograph of 1957, the discovery was in 10 years later, you can see the outline of these kimberlites. That's AK1. That's about 1.5 kilometers by 1 kilometer wide. Those are some of the other kimberlites that they were finding here in Orapa. And these kimberlites, there was hardly any Kalahari cover here. These kimberlites stood out as really nice features. And in fact, the AK1 that feature was used by SA Airways when they flew to London as one of their beacons on the way on their flight plan. So there is Gavin Lamont with Manfred Marks and Jim Gibson, the guys who really opened up this part of the world. It didn't take long to get the first samples out of the kimberlite, and these were small pits that were dug to 20 feet. They used a very simple plant that they got from Kimberley. You must remember, exploration in a mining company is always the one that gets a squeeze on, so you do everything as cheap as low cost as possible. This is a rotary pen that the diggers use on the rivers, and this was used to get the first diamonds out of the sample. Later on, they used the more advanced equipment, some headgears and a DMS plant. Anyway, so the first diamonds, they came out. There's a photograph of the first diamonds from AK1, and it became big news at the time in the world. They then decided to do some airborne magnetics over the whole area, and this is a Catalina aircraft that came from Canada, and it was really the first airborne survey that was done for kimberlites, and they flew these on flight lines, and you can then pick up the magnetics, kimberlites having a slightly different magnetic signature than the surrounding country rock. And that's what the Orapa kimberlite looks like. It's now sitting at about close to 400 meters deep. And with depth, it's actually developed in two big pipes that's sitting on top of one big crater. And when this thing exploded, it left behind a big hole in the ground and filled with water and so on. And it was like a crater lake almost. This is what it looked like in 2017, 3 years ago. There you can see these are fairly big drill rigs for scale. And there you can see the development in the one pipe and their development in the other pipe. It's 118 hectares on surface. And it has produced, since discovery, has produced well over 400 million carats now. This particular pit is probably now close to 300 meters deep. And the grade of this kimberlite runs at about 90 carats per 100 ton. So you have to mine 100 ton to get 90 carats out of that. The kimberlite itself is 95 million years old. It's what we call part of the Cretaceous. And it provides a great employment for the Botswana government. What is interesting is that I mentioned it had a crater on top, and in the crater it had a crater lake. And there were some really interesting fossils that were found in these craters, in this crater, with some very nice insects and beetles, and also some plants and some flowering plants. And it was just about the time that the flowering plants and the fruity plants were developing in the Cretaceous. And it provides a very interesting story, the relationship of these beetles with the remnants of these plants found in this crater. Unfortunately, they mined away the crater, but we were able to collect quite a number of fossils, and there's quite a number of papers that have been written about that. The mine was opened in 1971 by Sir Kama and Harry Oppenheimer. And one of the things that they decided to do is to build a Botswana mining company in which the government and the Beers each had a 50% shareholding. It is something that was unheard of, but by these two, both these guys with tremendous amount of vision, it still is a very remarkable relationship. Sampling continued, and I'll just run through it a bit quicker now. This is in the Bechuanaland area. Initially, the sampling in 5 years prior to that, people had sampled close to the Bechuanaland area, had found nothing. But in 1969, they started sampling this area, and they started picking up a lot of ilmenite. The difference here with Bechuanaland area and Orapa is that the Bechuanaland area has a cover of about 50 meters of Kalahari sediments. So this is really where the termites is coming in. They've brought these grains to surface, and this is a map showing the density of the number of ilmenites per sample, and you can already see the outline of potential kimberlites. They found these are what we call heavy mineral anomalies, and they brought in a rig. They drilled the first targets and found nothing. And it's interesting that, again, the drill that they used was a drill that they had in Orapa. In Orapa, you don't have any cover, but the depth limit of this rig is 50 meters. The cover at Bechuanaland is 50 meters. So that's really why they missed the first holes, missed the kimberlite. But they pushed this rig a little further and then drilled into their first kimberlite at Bechuanaland. They found at least 9 kimberlites initially. I'm not going through all the details here, but the people in control there was a chap called Stuart Verco, and he had a team with Norman Locke. They were the 2 people that were really involved in the discovery and evaluation of that kimberlite. So interesting, Bechuanaland is actually 3 lobes. So it's got 3 pipes. It's about 54 hectares in size, about half of Orapa, but still very large in terms of general kimberlites. And the first drilling that was done, they had to go through the Kalahari sediments. They used a jumper drill, and the jumper drill is a machine that has a big chisel. The chisel hammers away, it bounces up and down, and it goes down fairly slowly. Every now and then you have to pull out the chisel and then put in a baler. The baler goes down and picks up the material, brings it out, and then the chisel goes down again. So the penetration rate of this drill was fairly slow. Initially about 5 meters per shift, but that certainly at depth started changing to about 1 meter per shift. And it was far too slow to do the evaluation drilling. In addition to that, the hammering of this chisel resulted in quite a high percentage of diamond breakage. And of course, that is not good for evaluation purposes, because you lose your value on your diamonds once you start breaking them. So this was replaced with rotary drilling, and they've then managed to complete the evaluation program. This is what Bechuanaland looked like. It was 54 hectares. It's a bit older than Orapa. It's about 240 million years old. It was commissioned in 1982, and it's almost produced as many diamonds as Orapa has at the moment. There you can see how it's covered by quite a lot of Kalahari sediment. So it's quite a lot of stripping that had to take place before they could actually start mining this ore body. There you can see the 3 lobes. This is now at depth. This pit is now almost 700 meters deep. It's a massive mega pit almost. Its grade, it's also much higher than Orapa. It's sitting at about 130 carats per 100 ton. But note the value of the diamonds. On an average, about $200 a carat, and the cash cost is about $90 a carat. So you can see the revenue of this mine. It's probably the richest mine of any commodity in the world. That's the size of the pit. It's a large pit now. There's the photograph of the pit. And to give you an idea of the depth that they cut what they call cut 8. Cost $3 billion to open cut 8, because you have to take out quite a lot of country rock to get to the kimberlite now. And it's twice the height of the Eiffel Tower. That's where we're sitting at the moment. And the production, this mine produces between 12 and 15 million carats per annum. It's really one of the biggest producers and Orapa together. The cost I mentioned was $3 billion to make that cut down to that level, and that'll take the mine through to 2028. But this is the sort of revenue that this contributes to as a country. Enormous amount of funding that the country has developed, and also the number of people that it employs. And you can see that in the country. All the roads are paved. There are some good hospitals. There are good schools. The money is really put into the right perspectives. Obviously, one of the problems that you're having with these steep pits is failures. This was a failure in 2012, which set the production back a bit. But generally, Bechuanaland has produced not only a lot of diamonds, but also some very beautiful diamonds. This is a 236 carat diamond that was sold for $19 million or 90 million pounds in 2013. It had produced a 446 carat stone in 1993. And it's probably produced a lot of big stones, which we don't really hear about much because it's not De Beers' way of doing business. Just to continue a little bit further, the big mines in Geolong over here, Orapa here, had been found, but the law in Botswana is such that if you take out a license, you do prospecting there, and then you drop the license, you have to hand in your results, and these are made public, so people can go into the Geological Survey in Gaborone, and it was in Labatsi, but it's now in Gaborones, and you can take out. You can look at up reports and you can then build on that. And this is what these people did. They looked at all the sampling that De Beers had done. These hatched areas are areas that are covered. The crossed hatches are areas where they found positive samples. But because De Beers were so busy in evaluating their Orapa and Geolong deposits, they didn't have time to follow up some of these other areas. And this is what Falconbridge did, Chris Jennings and the guys. They took up these areas where De Beers had found positive samples, and instead of sampling, they had a very different approach. They used airborne magnetics straight away, and were able to find lots of kimberlites in a very short period of time. Lots of kimberlites at Sabong, at Kokong, and even here in Gopi in the Central Kalahari Game Reserve. So their approach was very different, and they discovered many, many more kimberlites. Unfortunately, none of those ever became a mine, except there's a kimberlite in Gopi in the Kalahari, Central Kalahari Game Reserve, and they, for the first time, used a helicopter to do the sampling. They sampled on a grid, and in 6 months they were able to cover this whole central area, which De Beers would have taken a couple of years to do by foot. And they found numerous kimberlites, among others this Gopi 25 kimberlite. That's what Gopi 25 kimberlite looks like. It's got about 80 meters of Kalahari cover, so a real challenge. It's about only 10 hectares in size. You can see these kimberlites are getting smaller. It's got a grade of about 27 compared to Geolong of 130, and it's got 80 meters of cover. So a very different economic kettle of fish that's set and developed for a long time, and I'll get back to that in a minute. Just to other kimberlites that contain some diamonds right on that central eastern part, close to the border with South Africa. A couple of kimberlites were found there. They contain some diamonds. They don't have any cover. They were mined for a couple of years, but they really don't, because of the quality of the diamonds, they didn't turn out to be economic, and they were dropped. But one thing that has happened, certainly in the last decade, is that people have started looking at some of the kimberlites that were found by De Beers and other companies and re-look at them with new technology. And this is what we call AK6. It's the Koroa mine also in the Orapa area. After the initial discovery, it was thought that the kimberlite was only 3.3 hectares in size. But it turned out that this kimberlite is much bigger, and it's because the part of the kimberlite has got some vessel capping on it, and therefore you don't see it with magnetics. And so some of these kimberlites have been re-looked at. The grade of this kimberlite was initially thought to be 3 carats on the ton, turns out to be a lot more than that. And this particular kimberlite, AK6, have produced some of the world's magnificent diamonds. This is a 1,000 carat stone, 1,100 carat stone that was found in 2015 in this mine. That stone was sold for $53 million, one diamond. This one was found almost in the same week. It's an 800 carat diamond that was sold for $63 million. And more recently, they found an even bigger diamond, but obviously not as clear as the other two, of nearly $2,000 carats. Now, the biggest diamond ever found was the Cullinan diamond in Premier Mine in Pretoria. That was over 3,000 carats. That's now part of the crown jewels in England. But it's very rare to find, and almost impossible to find these big stones, not just because they're so rare, but also because mining operations tend to break these diamonds at times. This mine has produced, as I mentioned, 2 diamonds over 1,000 carats, 6 diamonds over 300 carats, and so on. It's not a great producer. It only produces about 200,000 carats per annum compared to 12 million carats for Bechuanaland, but it does produce some of the best, nicest looking diamonds that are around. And some of the things that they have introduced, they don't crush the kimberlite rock. They use a autogenous milling technology, which is much more gentler on the diamonds. And they also have an X-ray transmission facility that allows for quick passing of coarse material that can pick out any big stones early on before it goes through the whole metallurgical process. So this technology has certainly helped them to find and preserve some of these big stones and preserve some of the value of those diamonds. There are the Hopi 25, which I mentioned early on, with the 80 meters of cover. The company did try and put a decline in through the 80 meters sediment to the kimberlite. It worked for 2 years, but they had a lot of water problems. You can imagine this is 80 meters of Kalahari sediment, soft sediment, through which they are trying to shaft. And it was disbanded a couple of years later in 2017, and it was recently sold to a local group that be interested to see what they're going to do with it. So in summary, this is when the first, this is just a graph to show you the number of kimberlites that were found in Botswana over time. The first 10 years was really De Beers doing most of the discovery, and it includes the Orapa and the Geological pipes. And then Southern Era had a big go at it. They found lots of kimberlites, unfortunately nothing that was mineable, and so on. So there have been phases, but one can see how it slowly tails off, that most of the country has been reasonably prospected. But I think there is great potential to still look for other kimberlites using more modern technology. So when the next when the diamond market picks up, I'm sure there'll be more interest doing that. And this is the final slide that I just wanted to show you. This is shows you what it's done to Botswana as a country. The GDP in 1970 was $84. The GDP at 2018 is now over $8,000. And that's really what it's done for the country. It's done a massive injection of development. And you can see how the GDP has performed against that of Zambia and Zimbabwe, which is probably not surprising. But the money is used in very effective ways. They've really upchecked their education system. They've got several universities, 2 universities now. Schooling is of a high standard, and Botswana is a very peaceful and great place to be. So I think that's all I have to say. I probably went over my time a bit. Thank you.
Excellent, Mike. Thank you very, very much. That is fascinating. I don't know whether you're more of a historian or more of a geologist, but certainly that introductory part was also very interesting. You know, there's an annual or a biannual Alex du Toit lecture series.
Yes,
and
that's right.
We had, I think it was 2 years ago, where we hosted the series here in Hermanus, and the hall was packed. It was a wonderful explanation of some of the things that Alex has done. So he certainly is one of the great geologists of our time. I want to ask you 2 quick questions, please. I didn't realize that the Cape Val Craton extended all the way into Botswana.
Well, the Cape Val Craton does extend in Botswana, more in the southern part, but there's another craton that has been welded onto the Cape Val Craton that's called the Zimbabwe Craton. And we sort of called both of those together the Kalahari Craton, and in between you have the Limpopo, what we call the Limpopo Belt. So it's not just the Kaapvaal Craton, it's two cratons really that are being welded together that produces the well. And in fact, the Orapa kimberlite punches through the Zimbabwe craton.
Now, how do they mine? Do they blast and then just scoop up the remain, or is there a different way of mining? And secondly, once it's done, how will the area be rehabilitated, if at all?
Well, if a kimberlite is normally mined as an open pit initially, so they will mine that like Orapa and Bechuanaland, those photographs I showed you, as an open pit. But of course, your overburden stripping ratio becomes too high, and then you have to make a decision whether you can continue open pitting or whether you should rather go underground. And a lot of mines then go underground, like the Kimberley mines in Kimberley now, and Venetia in Limpopo has just gone underground. And these mines as well, the open pit will go to 2028. They're talking about another cut 9. But after 2040, I guess they would have to think about going underground. So then you'll continue underground mining. There's different techniques. I'm not a mining engineer, but a lot of that technology is applied in Cullinan Mine and Finch Mine and places like that. So that's a fairly standard technology. With regard to with rehabilitation, it's very rarely that you can fill in these holes. You saw the talk of Marsfontein. Marsfontein still stands as an open pit full of water. And I think you can actually make quite a nice environmental, an environment there for birds and for all sorts of other things. I can only recall one kimberlite that was filled in, that is the De Beers mine in Kimberley, which was next to the railway line. And the railway line there was a chance the railway line was going to fall into the pit, so they had to fill that in. But it's not regular that they fill these holes.